Testing the hypothesis that the standard deviation of population 1 is different than the standard deviation of population 2. So standard deviation of 1 equals the standard deviation of 2. So when you're hypothesis testing with paired things, this is this is fun because it's different in StatCrunch. So this is possibly why it's very confusing, is because how you write it in here is completely different than how you write it in StatCrunch. So our null hypothesis for paired ones is that they're the same. And so that's basically always what it is, that they're the same. And then the alternative is that they're different, or one is smaller than the other. But here they tell us specifically that one is smaller than the other. And we're assuming the populations are normally distributed. So in order to do this work, we want to use the F distribution, letter F as in Frank. In order to do that, the samples have to be independent, and they have to be normally distributed. That's actually critical. You can't do an F distribution if the population is not normally distributed. So just something to keep in mind. Okay, so we're going to go into StatCrunch now. All right, so for StatCrunch, we're going to do stat. We're going to do variance statistics. So standard deviation and variance are related, and every time you see one, you kind of got to think of the other. So the variance is just the square of the standard deviation. And so we're dealing with 2 samples, and we don't have data, we just have summary, because the S is the sample standard deviation. So we're just given a total number of items in the population, and then we're given the sample standard deviation for each of those 2. So we're going to say with summary. So here's the challenge, and I actually put this in my quick tip that I sent out yesterday. StatCrunch asks you for the variance, but the problems in the homework are talking about standard deviation. And so you have to make sure you're paying attention that the variance is the standard deviation squared. So you have to go in and you have to manipulate all these numbers to be able to use StatCrunch. So we're going to go to use Desmos. I want to make this not there. Sorry, I'm trying to make this over here. Sorry, Desmos. Graphing. Okay, so variance is standard deviation squared. And so for population 1, for sample 1, we're going to take 3.2 and we're going to square it. And so it's 10.24. My n is 18. And the other one was 4.8. So 23.4. And the sample size is also 18. Okay, so here's another thing about this. Now, think about if I say x equals y, and then I can also say that x divided by y equals 1. It's another way to say the same thing. And so that's basically what we're saying here, is this is saying that the variance, which is the population standard deviation squared 1 is equal to the standard deviation squared 2. So this is the same as what we wrote over here. But this is with standard deviation of the population, and this is variance of the population. But it's the same thing. So, and again, this is in my quick tips. You just want to make sure you write it down so you remember that it's just written differently, but it means the same thing.
Okay.
Okay. So yeah, so that's kind of, and for my question, it was 0.01. It says to use the p-value approach. You can actually use either one, but, and then I always use the plot because I like the plot. It helps me figure stuff out. So my p-value is 0.104, which means that this is not really these are not very different. If they were very different, the p-value would be smaller than my level of significance. And that's clear when we look at the graph, because the areas in red are pretty big. So if the p-value was really tiny, the areas in red would be really small, and they would, because that's the p-value represents the area. So this is basically saying 10% of this whole curve is in this area. And that's not really that unusual if there's a 10% likelihood that it's going to be in that. And so so we would not be able to say that they're different. So we're going to go ahead and finish this problem. The p-value is, I didn't write it down, 0.104. Since the p-value is greater, so these always go to the same. If it's greater than the level of significance, we fail to reject, do not reject. And therefore, there is not sufficient evidence. So do not reject always goes with is not. Reject always goes with is. And so these three always kind of go together. And actually on the exams and stuff, if you have three that match, and they match your answer for your p-value, even if your p-value is wrong, if they match it correctly, I give credit for this conclusion. Okay. But they have to match. Yeah, that's what I want to see, that is that all three go together, because that's part of me seeing that you sort of understand what's going on. So that's just a tip for that.
Okay.
Yeah. Just
perfect. Yeah. Thank you so much. That makes more sense.